Now we're going to go over just a few species, some of which I'm sure you're familiar with. The first is Eurasian watermilfoil. And this can survive in nearly any environment, lakes, ponds, reservoirs, and slow-moving rivers up to 30 feet in depth. So you'll see this one throughout the lake. It doesn't just hug the littoral zone like some others. It has a wide tolerance for environmental parameters like salinity, temperature, and pH, and it does especially well in areas that are disturbed or have high nutrient loading. And while the plant does die off in the fall, the roots are able to survive through the winter, and new stems will begin growing in the early spring once the water reaches about 60 degrees. So this is what helps to make this plant one of the earliest appearing plants in the season, which assists in its ability to grow into dense colonies and crowd out native species. Now, this is a plant that reproduces both through fragmentation and through seed. And fragmentation, it actually auto-fragments. So it, towards the end of the season, little pieces of the plant will break off and disperse on their own. And then it can also fragment from us either pulling it or getting stuck in boat motors. So how do you identify it? It's got a thin stem, which is variable in color. It can be, pinkish or a light green in some cases, or a dark green in some cases. The stem is up to about 10 feet. It has 4 feather-like leaves, which have this blunt tip here, and each one of those leaves is comprised of 14 or more leaflets. The leaves are whorled, so they appear in a circle around the stem, and they're widely spaced. There's usually about an inch or so space between the whorls, which is kind of its hallmark. It can also have a floral spike. It doesn't always have flowers, and you don't necessarily need it to identify it, but just in case you're concerned, because there are some native milfoils, this could be helpful. And that has a small 4-part flower, which again doesn't always appear on the spike. All right, curly leaf pondweed, another really common one to this region. This can be found in both estuarine and freshwater lakes, ponds, reservoirs, and rivers or streams up to 25 feet deep or so. It can tolerate low light and low temperatures, and as such, it thrives in polluted and turbid waters, as well as in really cold waters. So that's what allows it to outcompete native plants that can't withstand those same conditions. And the ability to survive colder temperatures contributes heavily to its competitive edge, as demonstrated by its fairly unique phenology. So this plant appears in the early spring, and it dies back in mid-July, which is very early. But curly leaf pondweed can still survive throughout the winter in its overwintering form. And then it begins rapid early spring growth from anywhere from 8 to 10 centimeters per day once the waters reach about 50 degrees. And so that's 10 degrees colder than Eurasian watermilfoil. So it's able to quickly colonize the water column far sooner than native plants. And it does this using turions, or overwintering buds. Each plant can drop up to 150 of these per season, and the turions can then be consumed by waterfowl. It also spreads through fragmentation. Still, there are some benefits to curly leaf pondweed, as I alluded earlier. It has been suggested that in polluted waters where native plants can't survive, this plant might actually provide habitat and food for waterfowl and wildlife. And it's also been shown to have some antimicrobial properties against bacteria like E. coli, as well as remove contaminants from the water. Again, this one's fairly easy to identify. You can't really confuse it with very many other of the native pondweeds, very distinct, but the stem grows up to about 15 feet. And it has these rigid, narrow, oblong leaves with wavy, serrated, or spiny margins. It looks almost like a piece of bacon or a lasagna noodle. And that's what a lot of people say. And the leaves are alternate and get really dense towards the end of the stem. And the leaves are typically semi-translucent and reddish green in color. Color is not something I usually use to describe plants, aquatic plants, just because they can change a lot based on water quality. But that's something you'll usually find with curly leaf pondweed. It doesn't have any floating leaves like other pondweeds do, but it has a small floral spike, which I've circled here. And then it's got those turions. So this is what they look like. They're a little bit less than an inch, I'd say, a few centimeters or so. They can vary in size, but these will drop off at in mid-July. All right, fanwort. So this is a submersed perennial plant that can be found in most shallow freshwater habitats, but it does best really in slow-moving or stagnant waters because it's really easily prone to fragmentation. The plant needs muddy or silty substrates, preferring waters less than 10 feet deep, but it can be found up to 30 feet deep. It's really tolerant of turbid waters with high productivity and a wide range in pH, but it's actually sensitive to some things. It's sensitive to alkalinity and elevated levels of calcium. Now, because this plant is easily fragmented, it's developed quite a survival mechanism in the form of a thick mucus that actually allows it to survive free floating for up to 8 weeks. And those fragments are able to develop new roots and rhizomes, which increases its chance of spreading and establishing into new populations. It also produces seeds from a single emergent self-pollinating flower. That's obviously not going to be as common as fragmentation. So this stem can get really long. It's submersed and reddish purple in color, up to 32 feet. This image here, this is one of my crew members. This is one plant. So that's just how long it can get. It's got really thin leaves that are vein-like or spider-like and fan-shaped. They are opposite along the stem, and there are two leaves per petiole. There are some native species that might look similar to this, water marigold and crowfoot are two that I can think of off the top of my head, but their leaves aren't on these long stems here. They're right up next to the petiole. The plant loses its shape out of water, so it's fairly wispy. And it does have a flower. It's very small, emergent and white, and it might be on the top of the surface, but early in the season, it can also be submersed underwater as well. And that flower blooms from May to September. Okay, brittle naiad. This is one of the most underreported species in our region, but we think it is probably one of the more widespread plants. This can tolerate both freshwater and estuarine environments. It also likes slow-moving or stagnant lakes, ponds, and rivers up to about 18 feet deep. It does really well in shallow, turbid, eutrophic environments. And it's able to easily replace native naiads that are not as resilient. Brittle naiad can reproduce through fragmentation, but its main method is through small one-seeded fruits that release seeds in September and then germinate in the early spring. Those fruits and seeds are spread by, or can be spread by waterfowl as well as on boats. But you'll see when we learn how to identify it, this growth really allows it to go unnoticed. So this is kind of the quintessential aquatic invasive plant example. You don't notice it right away because it's just very low growing. And that's due to it's a very short stem. Its stem is submersed and heavily branched, but it only grows up to about 4 feet long. So it's a very short plant, and it can have sort of more of a horizontal growth pattern as well. The leaves are stiff and thin with serrate or spiny margins, and they're very heavily serrated. You don't need a hand lens or anything to see this. As soon as you pull it up, you'll see. The leaves are opposite, but they do appear whorled, and they have this compact, bushy growth, almost looking like tiny trees. They can have 1 to 2 very small flowers at the leaf axils. And then there are a lot of native naiads as well, but they're not nearly as stiff or as dense as brittle naiad. And most of them also don't have those serrated edges. There are some native naiads that do have the serrations, but they are not nearly as stiff as this plant is. Okay, and another one that I'm sure needs really no introduction, but water chestnut. This can tolerate pretty much everything, but it does best in slow-moving lakes, ponds, rivers, or streams less than 15 feet deep. It does really well in eutrophic environments with high productivity, and it needs muddy substrates. It can grow into really dense mats. Its rosettes can top on top of each other up to a foot in depth. This picture right here is only 1 or 2 years old, this infestation. So the rate of reproduction for this plant contributes to its exponential growth, obviously. The primary form of reproduction for water chestnut is through prolific production of seeds. Each seed can grow into 10 or 12 stems, and each one of those stems can host up to, or each one of those seeds can host up to 20 rosettes. And in turn, each rosette can produce 20 seeds, which then drop off in August. These seeds can begin germinating during the next growth cycle, or they can even lay dormant for up to 12 years in the sediment. The seeds can then disperse, obviously through currents or by waterfowl, and entire rosettes are regularly seen attached to boat motors and trailers. The timing of the release of seeds is crucial for managing this plant because this is the most likely means for growth of an infestation. So removing the rosettes before the seeds drop is really paramount to achieving any sort of eradication if that is your goal. All right. Water chestnut has buoyant cord-like stems up to 16 feet. It also has like feathery roots, which might sort of look like leaves. Its leaves are triangular and serrate, heavily serrate, and they're arranged in a floating rosette. It also contributes to its buoyancy as its air-filled petioles. It has a really small white flower, which is probably not going to be necessary for you to identify it. But then it's also got these 4-horned, sharp, barbed nutlets. The green nutlets are alive, but the black ones are not. The black ones are what you see floating on the surface of the water, and those are the spent water chestnut seeds. Now, we do have a new Trappist species that is not yet in our region, but everyone should be aware of. The major difference is it's purple on the underside as opposed to regular water chestnut, which is green. So if you see that species, if you see water chestnut and you've never seen it before, flip it over and give it a good look and make sure you, report it. You can either email it to me or report it in some other way, iNaturalist or IMAP Invasives or something. But that's something we all need to be on the lookout for. All right, and the last plant we're going to go over is hydrilla. So again, this one really likes any environment. Freshwater, brackish lakes, ponds, rivers, and canals can tolerate a lot of different changes in nutrient availability, salinities, light conditions, and temperatures. And in our region, we have the monoecious biotype. That means each plant has both male and female parts. There are 2 biotypes. We have monoecious up here in the Northeast. But down in Florida, you've probably seen video footage of the hydrilla in Florida. That is a completely different biotype than what we have here. This reproduces through fragmentation, turions, and tubers. That's kind of why this plant gets its nickname of the world's worst aquatic weed, is because it really, it's got the trifecta. It can reproduce through so many different means, and that's what makes management tricky and imperative that it gets done correctly. The tubers are small potato-like structures, which we'll look at on the next slide, and those can stay viable in the sediment for several years. So you can't just pull the plant and be done with it. So identification. The stems can grow up to 30 feet long, and early in the season during its growth, it grows several inches a day. The leaves are lance-shaped and serrated or spiny. So this is one of the hallmarks for this plant to help you separate it from that native waterweed that I showed at the beginning. It has leaves in whorls of 3 to 5, but usually 5. But it's important still to look really closely at it, because early in the season it might only have 3 leaves, or if the plant gets damaged, it might only have 3 leaves. So 5 is typical, but that doesn't mean it's always going to be 5. And then the tubers or turions, these little potatoes that sit underneath the sediment. These are pretty small, just a couple of centimeters. So here's a good example of comparing hydrilla with some other species. So we're not going to go over this one, but Brazilian elodea, this is another invasive plant, and then native elodea. And this just shows you the differences. So Brazilian elodea typically has leaves in whorls of 6. It's also a lot longer and denser growth. And then elodea only has 3 leaves per whorl, and it also doesn't have those serrated edges. All right, so once you feel like you got a little bit of a handle on how to identify some plants, and or you go out with a field guide, you're going to want to do a survey of a lake before you try to do any sort of management. So we have the Aquatic Invasive Strike Force, which is a seasonal Trail Conference Conservation Corps AmeriCorps crew. And what the crew does and what our mission, we're committed to preventing the spread of aquatic invasive species through education and outreach to active users of New York's waterways, while also supporting management efforts through early detection surveys. And then we also have different components. We do monitoring through the surveys. We also do management, primarily water chestnut removals. And then there's also professional development for the crew. So the goal of the crew is to conduct submerged aquatic vegetation surveys throughout the lower Hudson region. And then we record invasive and native species presence, absence, and abundance. And then we upload those results into IMAP Invasives, as well as our own database, and create reports to help assist in management priorities. So we really try to be the boots on the ground and the people to sort of bridge the gap between what we assume can be found in the Hudson Valley versus actually determining the full distribution of some of these aquatic invasive species. So now I just want to share just a quick snippet of a video of how we do that survey. This just goes over how we do the protocol for our vegetation survey. In order to accurately map occurrences of aquatic invasives, the Aquatic Invasive Strike Force performs submerged aquatic vegetation surveys. This is especially important for early detection of new species, which can aid in rapid response for possible eradication of small infestations, and it also aids in management options for existing infestations. We perform surveys by first laying a grid over an entire lake and placing survey points every 60 meters, about 200 feet. We load these points into a GPS unit and navigate to each individual point, focusing on locations within the littoral zone. Once we arrive to a point, we perform 2 tosses of a weed rake and record the plant species we find. To perform a rake toss, we allow the rake to sink completely to the bottom before retrieving to guarantee we have an accurate sample. Once the rake is retrieved, we record the overall plant density as well as percentages of each individual species. We collect any invasives we find, being careful not to toss any fragments back into the water. All right, and then, we repeat that throughout the entire lake. So this is an example of how we would set up for that. This is Chodikee Lake, which is in Ulster County or Orange County. No, I can't remember. But you can see we put this grid over the entire lake, and that's how we get our survey points. And then we visit all of those points. Now, determining density, it's kind of subjective. It's not an exact science. This is just an example of kind of the scale that we use. So we record either trace density, that might just be a few plants. Sparse is, I would say, covers about half of the rake. And then moderate would be covers 3/4 of the rake. And then a dense density would be recorded if it covers the entire rake, if we can't hardly even pull it out of the water. And then here's an example of what those results look at if we're like mapping out the actual plant beds. In Chodikee Lake, they have a lot of native plants, but then they also have curly-leaf pondweed and water chestnut. So we just separate it using different symbols. And then we do surveys twice. So we do one at the early part of the season and one at the later part of the season. And that's obviously because as we talk about curly-leaf pondweed, it shows up really early and it dies back fairly early. And while it'll still be there, you're not as likely to catch it on the rake when it's in its diminished, like winter form. So we find it really important to do these at different times to make sure you're really capturing everything. And then hydrilla doesn't actually start really growing until, late August, September-ish. So if we only did a survey in June, we would probably miss any hydrilla. All right, so now you've learned to identify, you've gone and done a survey, now you want to actually do some management of those plants, whether they're native or invasive. And like I said, native plants can become a problem too. So there are a few different methods. I'm only going to talk about the ones that I feel are most appropriate. And during the question and answer, if you have any questions about other management practices, I'll be happy to talk more about those as well. But I just want to talk about the ones that I think are most appropriate. So hand harvesting is potentially free, if you're just doing it by yourself and you don't have to, pay anyone in either money or donuts to help out. This is really great for early detection and rapid response of any plants, really, as long as you're careful. So yeah, low risk if careful. And that's just due to fragmentation. Obviously, if you're pulling urasian watermilfoil or hydrilla, you wouldn't want to just pull quickly. You need to make sure you're getting the entire plant so that you're not releasing fragments back into the water. There's not usually any pushback, from anyone in the community because it's you're not using chemicals, you're not tearing up the sediment, you're not doing anything really. So it's and it's fully selective, so you're not going to harm any of the other plants, any of the other native plants that you might be trying to save. The problem, though, is that it's not effective for large-scale infestations. So it really should only be used in conjunction with another treatment method in those situations, or as a follow-up, maybe just to get the stragglers that weren't gotten with other methods. It's also not effective for plants with extensive root systems like white water lily. You're not going to be able to manually pull up that entire rhizome. So this is best for water chestnut, early stages of Eurasian watermilfoil, as in early stages in the infestation, as well as curly-leaf pondweed and coontail. All three of those, if it's early enough and you don't have that much of it, you can effectively pull them and actually, try and keep it back that way. Benthic barriers, these are, can be fairly inexpensive. And it's simple, really. It blocks the sunlight and restricts the growth. And it can be cheap because it can be handmade, maybe a tarp and some rocks. If the water is shallow enough, you can do it yourself. It needs early spring or post-treatment installation of other sort of treatment. The problem with benthic barriers is that there's extensive maintenance required. You have to go down and make sure that you're cleaning off the mat. You have to make sure you're moving the mat around if you have a really large infestation. So it's really best if it's just a really small area that you can cover with one tarp. But you also can get plants growing out from underneath the mat and then back on top. So it's not the best, but maybe if you have a really small infestation, it could be worth it, especially if it's shallow. And you can easily reach it. The problem with this, of course, is it's non-selective. Unless you have like a monoculture, it's going to also target any other plant that's growing in the same area. But it works for rooted plants. Probably not super effective for floating leaf plants, but like submersed rooted plants. Hydro raking. So this is a mechanical machine that rakes, cuts, and removes all roots and plant matter. It's obviously very expensive and a permit is required, but it's great for shallow areas. But it is non-selective and it stirs up the sediment so it can increase turbidity. It can also release excess nutrients, which can then in turn lead to algal blooms. It needs to be done several times per year. The reason why I include this, though, it's one of the only options you have for water lilies. If you have a water lily, you know, what you would think is a problem, hydro raking is kind of the only option you have because it's the only thing that's going to really get those rhizomes. Okay, and then mechanical harvesting. This is a whole lake strategy. So it's not something you're just going to use to target a small area. Not only does it remove the plant, you know, it removes the excess biomass and the excess nutrients. So some of these other things, you know, if you've got a really bad sediment problem and a really bad nutrient problem, then just letting all of the plant matter sink to the bottom of the lake isn't going to help you very much. So this actually removes the biomass. And it can deplete the seed bank over time. But it's not going to completely uproot all of the plants, which is a good and a bad thing. It's good because if you have really low growing native plants, it's not necessarily going to hurt any of them. But there is a high risk of fragmentation of other plants. It's also aesthetically displeasing. You have this machine sitting on your lake all season. But it's best for water chestnut with no other invasives, and that's due to the fragmentation issue. And it's really best for water chestnut if it's, you know, the entire lake is covered in water chestnut. If you've got a smaller infestation, I do not ever recommend harvesting just because it's not necessary. You can, you know, get to the entire infestation in 1 year. You'd be better off manually removing it. And then herbicides. So there's contact herbicides that hits the top of the plant, and then systemic that hits the roots. That kills the plant, and when applied early enough can eliminate new additions to the seed bank, obviously. And it can be extremely selective. A lot of herbicides are targeted specifically towards certain plants. It's more effective in a shorter amount of time, so you're not having to like constantly mow the grass with a mechanical harvester. An herbicide treatment can take just a couple of years to be actually effective. Obviously, it requires professional application and permitting, and it's good for all rooted plants. So just a quick note about herbicide, though. The concerns about the use of herbicides should be balanced against the ecological damage caused when invasive plants spread throughout the system. And that goes for native plants as well. If you have so many plants that it's choking out other species and causing nutrient problems, causing stagnant water flow, then using herbicide is probably going to be the least of your problems. So it's just something to think about. You know, a lot of people are hesitant to use chemicals, which is totally understandable. But you also need to think about, you know, how you're going to balance that, because ultimately, you know, if you're trying to manage, you want to manage for what's best for the ecosystem. All right, so that is all for the presentation. Obviously, this presentation was longer than the last one, but I'm available for more questions, so I'm obviously willing to stick around. If you have any questions you would like to ask, feel free and type them in the chat box, and we will discuss them over the video. Someone asked how much it costs to have a survey done. It's completely free. We're fully funded by the New York State Department of Environmental Conservation, so all of our services are free of charge. Obviously, we will always accept donations, but we do not charge a fee. And we're not here to replace lake management companies either. If you needed treatment, a lake management company would also come out and do a survey for you. But I think that the whole purpose of what we're offering to lake associations and you know, private homeowners too, but what we really like to offer is something maybe for people who aren't buying in yet. You know, especially if you're part of a lake association or a community and everyone's like, I'm not paying for that, you know, and then maybe they're not getting the real extent of the problem. Then if we can at least come in and share what you have and why it might be problematic, then I think it's a little bit easier for some people to say, okay, maybe we should pay for some treatment. But like I said, we're not here to replace big companies, but we just think we can help nudge it along for some people. All right, so thank you so much, everyone, for watching. There's been some things in the chat box about our surveys and what we do and what we provide. So yes, feel free to email me if you are interested in having us come out. We still have some space, especially at the end of the season, some space available to come out and do surveys. Or if it's small enough, I can usually come out and do it by myself too, so I don't necessarily need the whole crew. But then we provide a full report, and that includes plant information as well as zooplankton, invertebrates, as well as water quality parameters, just like baseline readings of 7 different water quality parameters. That's going to be it for me. Like I said, feel free to email me if you have any more questions. Thanks, everyone.